Hello guys, so today we are here to solve this problem called maximum sum of distinct subarrays with length k. In this problem we have to find the maximum sum. So this maximum sum we have to return. Okay, this maximum sum we have to return. Okay, my goodness, I'm not even able to. Anyway, so let's concentrate on the problem statement. So maximum sum of the distinct subarrays of length. Anyway, so we have to return the maximum sum of distinct subarrays with length k. Okay, so what do we mean by distinct subarrays? So first of all, what is a subarray? Here it is mentioned a subarray is a contiguous non-empty sequence of elements within an array. So typical academic definition, but subarray is a very simple thing. See, here k is 3. Okay, so we have to consider 3 consecutive elements of the array. So in this array 3 consecutive elements are 1 5 4. If we start from 5, then 3 consecutive elements are 5 4 2, and this is one another subarray. If we start at 4, then 4 2 9 are 3 consecutive elements, and this is one another subarray. If we start at 2, then 2 9 9 is another subarray, but in this subarray all the elements of the subarray are not distinct. This is the second condition. So this subarray we cannot consider for our problem. And also this, all elements are the same, so none of them are distinct, so this subarray also we cannot consider. So only we can consider 1 5 4, 5 4 2 and 4 2 9. Okay, 4 to 9. So 4 to 9 sum is uh, 15. Why? 9 to 11, and 11 plus 4 is 15, and 15 is the maximum value of all the distinct subarrays. Okay, and that's why we are returning 15. Okay, so with this understanding, let's try to solve this problem. So we will come to this, and then we will solve this problem. Okay, so first of all we'll find the length of the nums.length. Okay, n is equal to nums.length, and then what we will do, nums.length, and then what we will do that we will find out. Okay, we will find out the we will create a map. Okay, why we will create a map? Because we know that in a map all keys are unique. Okay, so a map is a place where we can store the frequency of the elements, as well as, since the keys are unique, a map can on its own guarantee us that the entries, if the entries of the map are of the same size as k, then it means that there is no duplicate entry, okay, in that particular subarray. So that's why we are using the map. Okay, so map of integer map is equal to new hash map, like this. And then we will also do long sum is equal to 0l, maxsum is equal to 0l, and then what we will do, that we will start a loop, and in this loop what we'll do, int I is equal to 0, I less than math.min. So let's check one thing here. What is the value of k? So k is less than equal to nums of length. Okay, so we need not do like that. Okay, we can just do I less than k, because k can be less than or equal to. If it is equal to, then we will do something else, but if it is less than, then I is less than k, and then plus plus I, like this. And then if I is less than k, okay, then what we will do, okay, if I is less than k, then what we will do, map dot put nums of I, map dot get or default nums of I 0 plus 1, and then sum plus is equal to nums of I, like this. And then after doing this, what we will do, that we will map dot put nums of I, map dot get our default nums of I 0 plus 1, like this. We will put a check if map dot size is equal to k, then we will do maxsum is equal to sum, because this is the first sum. So maxsum previous to this is equal to 0l, so without any check whether it is maximum, then maximum will just assign this sum value to maxsum. Now the other case, for int I is equal to k. So see here, I ends at k minus 1, so we are very we are correct in starting our I at k. I less than n plus plus I, and then what we will do, see, one element is going out of our sliding window here. So our window is of size k, okay, and at I is equal to k, the 0th element is going out of the sliding window, okay, because the first sliding window consisted of 0 to k minus 1, and when we reach at I is equal to k, I is equal to 0 is no more relevant for us in the current sliding window, so we have to get rid of this. So in order to get rid of this, map dot compute if present is equal to nums of I minus k n k v. So if v minus 1 is equal to 0 question mark, then we will be returning null, otherwise we'll be doing v minus 1, like this, okay. So we will be decrementing our sum value also, because this nums of I minus k is going out of the window, so we have to remove this, and then this new value nums of I is coming into the window, so we have to add that, and map dot compute. So in this also nums of I will be there, and then key value. So if v is equal to 0, then we will be returning 1, otherwise we will be returning v plus 1, okay. And here we'll be putting a check. If map dot size is equal to k, then we'll be updating our maxsum is equal to math.max of maxsum sum like this, and then we'll be returning maxsum. Okay, so let me run this. Okay, so this k is already used, so we cannot use this k, so it's better we use key. Okay, and here also we use key. Okay, yeah, so let me run this. Null pointer exception, so v is equal to, it will not be 0, it will be null. Okay, so this is running fine. Let's submit this. Perfect. So this is one way to solve this problem, but as we can see that this is not a very efficient way to solve this problem. I mean to say, surely we can try something else to make this solution better. And in order to do that, with I think if we if we don't use this collection framework classes map, then we'll be better off with this. So let's try to not use this map and then go ahead. Okay, so we will remove this map, and instead of this map, what we will do, that we will use an array. Okay, but to use an array we have to find out what is the range of elements that we are having in this particular nums array, because this problem says that the numbers are only positive values, 1 to 10 to the power 5. So max is equal to, let's say max is equal to nums of 0. Okay, and then for int I is equal to 1, I less than n plus plus I, max if max is less than nums of I, then we'll update our max is equal to nums of I like this, and then int array count map is equal to new int max plus 1, and this is there, and also we will do duplicates is equal to 0. Okay, duplicates is equal to 0. Why we are using this duplicates? See, the second condition says that all the elements of the subarray should be distinct. So even if there is one duplicate, so that is going to spoil the subarray, and we will not be considering that subarray. So we will take this duplicates count, and here instead of using this map, what we will do, we will use this if count of nums of I is greater than 0, then we'll be adding this duplicates count. Okay, and count of nums of I, obviously we have to increment that, because count map is the name, so we'll have to use the name count map here. Count map duplicates count is the name here. We'll have to use duplicates count here. Okay, and here we'll be checking if duplicate counts is equal to 0, then this. And now in this case, see here we don't have to do any map related thing. What we need to do here, so we need to put a check. So first of all, we have to realize here that in the count map, the nums of I minus k is getting out of the window. So when it is getting out of the window, it is getting out of the consideration. So we have to decrement this count map. Okay, and once we decrement this count map, what we'll be doing, we'll be putting a check. If count map is greater than 0, okay, so even after decrementing this count map, if it is greater than 0, then that duplicate count value, previously there was some contribution because of this count map, nums of I minus k. Okay, so what we'll be doing, we'll be putting this whole thing, and if it is there, then we'll have to decrement this duplicate count. Okay, so we have to decrement this duplicate count, and now what we'll have to do here, that we'll have to remove this. Okay, and then since new element is coming inside the so nums I is coming inside the window, so we'll have to increment this count map. Okay, and just now we have incremented this count map. So count map of nums I, if count map of nums I is greater than 1, if it is greater than 1, okay, then plus plus duplicate count, like that, and then this duplicates the count, this duplicates count. Okay, and then we will be putting a check here, duplicates count is equal to 0, like that. So here we have decremented this count map of nums of I minus k. Why? Because it is going out of the window. Even after decrementing, if it is greater than 0, it means there was some contribution by this count map. So we are decrementing that count map, so this value will be this duplicate count will be properly reflecting what is the actual duplicate value in the present window, because that nums of I minus k has gone out of the window, so that count should be removed from the duplicates count value. And newly entered nums of I element in the window, if that is also having count more than 1, then we should increment the duplicate count. And even after all this, at line number 27 we are finding if duplicates count is equal to 0, then we have to increment our maximum. And once we have incremented, we have done the increment of our maximum, then finally at line number 30 we are returning the maximum. So let's run this. Perfect. So this is what I wanted to show you, that when you are able to use the basic elements, the basic tools, you get a very fast solution, very optimal solution. I hope you like this. Happy coding, best wishes, keep rocking.